Swayam Prabha. Digital India. Educated India.
This is the last lecture for this course, Introduction to Aircraft Control System. Here, I would like to revise some important topic, what you have done in the last few lectures. First, let me rewrite in short form for the longitudinal motion, the linearized longitudinal motion. So we have the state space form x dot equal to ax plus bu. So in the x vector, we had delta u dot, delta w dot, delta q dot, and delta theta dot. And we had the state vector delta u, delta w, delta q, and delta theta. And we have B matrix. This is 4 cross 2 matrix. And this is 4 cross 4 matrix. This is 4 cross 1, and this is also 4 cross 1. And we have control here for the longitudinal motion, delta del A and delta del T. So now, if we want to find the transfer function, for example, del US with respect to del delta A. So for that case, what you have to do is what you have done in the previous lectures, the concept we have learned. So for this case, A matrix will be as it is, same. But B matrix we have to modify to find this transfer function. So here B, since we are considering so here there is two columns here, and first columns indicates the control delta del A, and second column indicates the delta del T. And so here we have to consider the first column of B matrix. So let me define, this is C1 column and C2 column. So B matrix will have C1 column only. And C matrix we have to modify accordingly. C matrix, since we are considering the output term, output state should be U of S. So C matrix we have 1, 0, 0, 0 into del U, del W, del Q, and del theta. So here, if you multiply these two vectors, will have del U. So here, this is the C matrix. So based on this, this kind of manipulation in the matrices, we can come up with the transfer function, this transfer function. And the formula we can use C into Si minus A inverse B. So in this case, the C matrix, this C matrix will be using this C matrix, and the B matrix will be using this B matrix, and A matrix will be remain as it is. So this is how we can find the transfer function delta US with respect to capital delta del A. Now similarly, we can find delta WS with respect to delta del A, and also the rest of the transfer function delta QS, delta del A, and delta theta S with respect to delta del A. So in these cases, only for all the transfer function for this one, B matrix will be as it is, but C matrix for this one, C matrix will be 0, 1, 0, 0, and for this C matrix will be 0, 0, 1, 0, and for this C matrix will be 0, 0, 0, 1. but B matrix will be this, the same B matrix will have, and A matrix will be same, and the same transfer function, this same function we can use to find the transfer function. So similarly, if you want to find delta US with respect to delta del T, so in this case, let me first write delta WS with respect to delta del T, delta QS is delta del T S, and delta theta is with respect to delta del TS. So for this transfer function, our A matrix will be same as it is, but B will be second column of control vector, control matrix, this matrix. So here we will take only C2 will be matrix, because here delta, capital delta del T comes in the coefficient of capital delta del T comes in the second column. So we'll consider second column in the system. And here similarly we can modify the C. For this case, C will have 1 0 0 0, and for this case A will be same as, and B will be C2, and C will be 0 1 0 0. In this case same as A, and B will be C2, and C will be 0 0 1 0. And in this case A will be same, B will be C2 column, and C will be 0 0 0 1. So this is how we can find the transfer function of the individual states with respect to different control input. So this is how we can find transfer function for all the states with respect to different control input. And whatever the learning we have in the first half of the course, the classical control we can apply to design the autopilot. So for example, if you want to design the autopilot for this system, delta WS with respect to delta del A, so this is the system. And please remember, this transfer function are basically plant transfer function. So if you consider delta WS with respect to delta del S, so this is basically our GP office, and we have the control input, which is basically delta del A S, and this is given by the actuator, and into the actuator we can apply some control U. It can be in terms of voltage, or because we are controlling the motor which can provide the required torque to the system, and this is the controller, and this is error is going to affect, and this is the summing point, and here we can set delta, or we can write delta W DGR, and this is the feedback. This is the feedback loop. Here delta WS is the output, it's the feedback, and we have sensor maybe here. So this is how we can design the classical control system for the any transfer function in the above cases. So this is how we can design the different, we can apply the different control technique here, and we can come up with our mission objective for the specific control system. Now, I'd like to highlight what are the topics are being covered in this course. Since this is the last course, I'd like to go through the conclusion, what are the different topics we have covered from different perspective. I'd like to highlight. So we have started from the conclusion. So here first we started with the need for study of the control system. Need for study So here we have discussed the importance of control system in aircraft for stability, performance, and safety. So these are the reasons why you have to study the control system. And then in the second part, we have studied understanding control system. Understanding control system. So here we have covered definitions of control system. Definition, what control system are and their importance in aircraft. And also we have studied about the types of control system, types of control system, which is basically the open loop and closed loop control system. We have introduced introduction to open loop and closed loop systems. And also we have discussed what are the components, in closed loop controlled system. So here we have discussed from different perspective like controller, then actuator, then plant, then we have discovered sensors. So these are the main different blocks exist in the control system. So these things actually comes under control, navigation, and guidance, and how these three different systems connected in closed loop such that the desired objective can be fulfilled. And then we have discussed about the linear LTI system, linear time variant system, LTI system. So here we have used the principle of superposition to fulfill the linearity of the system, and also how to identify if a system is LTI. And then next part we have discussed about the equilibrium point. That is one of the most important part in designing the control system. Equilibrium points. So here we have discussed definition of equilibrium point and its significance in the control system. Significance in control system. Also, we have discussed of how we can find the equilibrium point, finding equilibrium point. It is the techniques and examples. We have considered the pendulum system to find the equilibrium point. And then also we have used the small perturbation theory to find how can find the linearized system of the nonlinear system. So here we have used for the pendulum system, how we can apply the pendulum to the pendulum system, small perturbation theory, small perturbation theory. So here, introduction, and application for linearization around an equilibrium point. And then we started with stability analysis. So under this part, we have discussed the concept of stability. Here we have discussed what it means for a system to be stable at an equilibrium point. Then we have discussed how we can study the stability of the linear system. Linear system analysis. So here, methods to determine system stability we have discussed. Methods determine system stability. Then we started the transfer function, how we can study the transfer function and how it is important for control synthesis, classical control synthesis, transfer function part. So here we have covered definition and importance role in classical control synthesis. Also, we have covered the derivation of transfer function from the linear system, derivation from linear systems. Here we have given the process and examples. So here we have considered the aircraft attitude control problem. Then after the transfer function we have studied, this is the, so transfer function we can look at from different angles, open loop and closed loop. So we have studied open loop and closed loop transfer function. In the presence of reference input, noise in the system, and disturbance. Then we have discussed the how we can come up with the PID controlled system. So here we have discussed proportional control, derivative control, PD control, and PID control. And what are the significance of the individual controls in the closed loop control system? We have discussed them in detail. Then we have discussed the time domain analysis. So here we have covered two parts. So here we came up with the different specifications. For improving the transient response of the system. Then we have started with the steady state response. So here we have discussed in the transient response, we have discussed about our settling time TS, peak rise time TP, rise time TR, peak time TP, maximum overshoot. So how this specification are very important for modifying the transient response. So in steady state response, basically we have discussed the error analysis, how can we minimize the steady state error in the system. Then also we have discussed effect of disturbance in the control system. And then we have discussed the how can verify the closed loop system what you are having, whether it is stable or not. So for that, for the direction, we have come up with the Routh stability criteria. So here we have come up with the concept of marginal stability. How many poles are on the right hand side based on the polarity changes in the first column in the Routh table we have discussed that part as well. And then we have started with the root locus method. So how we can graphically represent the locus, the pole, how the poles are changes in the S-plane we have discussed in detail. So here we have discussed the how the locus of the poles moving in the S-plane as we change the gain from K to 0 to K infinity. So we have discussed details how we can come up with the root locus and how we can study root locus. Basically, we study how we can design the root locus plot for the open loop transfer function and how we can study the closed loop system behavior. Then from the concept of root locus and Ziegler-Nicholas method, from the concept of root locus and Ziegler-Nichols rule, we came up with the PID control design. And we had many examples how we can come up with this PID controls using the root locus and Ziegler-Nichols method we have discussed in detail. Then we have shifted our attention to the frequency domain. In frequency domain, we have covered the first we connect the time domain specification with the frequency domain specifications. So basically the relation between frequency merging with time domain specification like TR, TS, TP, and maximum overshoot. So this is we have done. Then we have started the frequency response, how we can see from the body plot. We discuss the body plot. So here we have discussed the how we can come up with the magnitude and phase plot for varying frequency. So here we have discussed also the phase crossover frequency and gain crossover frequency, and which gives us the gain margin and phase margin, and which also based on the margins we can also come up with the relative stability based on relative stability we can come up with the whether the system is stable or not. We have also detailed a discussion on this part. Then we have concluded on example on aircraft attitude control problem using PID control. So here you have used the frequency analysis concept in frequency analysis. So this is how these are the contents we have discussed in the first half in the lecture in the classical control part. Then we started how we can come up with the aircraft motion in 6 DOF. So then we have started the 6 degrees of freedom equation of motion of the aircraft. So here we came up with the two sets of equation. One set is represented the longitudinal motion. Another one is the lateral directional motion. So for both the cases, we have came up with the linearized model using the concept small perturbation theory. After the linearization being applied to these equations, we came up with the system in form of x dot equal to x plus bu, which is basically the state space model. So here, then we came up with different approximations. In approximation for the longitudinal, we had for the longitudinal motion, we had two approximations. One is the short period, and one is the Foucault or long period. So these are the motion are characterized by the roots of the characteristic equation or the roots of the system matrix. So here we have also discussed the dynamic analysis, how these motions are being discussed based on the period, cycle, and time to half and full magnitude. Half, or we can say 1 magnitude. So these are the topics we have covered in the longitudinal approximation. Then we also discussed about the approximations in lateral directional motion, lateral directional motion. So here we came up with the 3 different approximation. One was the spiral, second roll mode, third Dutch roll. So these are the approximation we came up with the roots of the characteristic equation. And based on the characteristic we came up with this kind of approximation based on the eigen based on the damping ratio and natural frequency of the roots. We came up this kind of approximations. Then also we have discussed the dynamic analysis for these 3 motions using this concept, what we have done for the longitudinal approximations. Then we discuss how we can come up with the transfer function for the state space model. So here x dot equal to ax plus bu. This is the state space model, and how we can come up with the transfer function for the different states with the different controls. So here we have used 2 methods. One method was a brute force method. Here we have used the Cramer's rule. And another method was we had SC into SI minus A inverse B. So this is one method, and this is another method. And using these 2 methods, we can come up with the transfer function for all the states with respect to defined inputs. And once we have the transfer function, we can apply the linear controls, what we have done many times in this course. Suppose this is the plant, which is written in terms of transfer function. This is basically GP of S. Then we can provide the control, which can be your aileron or elevator, propulsive force, which is maybe delta T. And these are the control inputs, which is going to the plant, can be provided by the actuator onboard system in the aircraft. And this actuator are affected by the control input, which can be given by the controller. And this controller, how we can come up, this is we have discussed throughout this course in multiple examples. In the first part in this course also we have come up with different concept how we can design this PID control. So in this course mostly we have designed the PID control. The different examples we came up. And here if you want to have desired value x desired to be tracked, and negative feedback, and this is positive, so error E of S, and this is for example x of S is the output. So how we can design this control effectively with the concept we have discussed in this course, which can help us to track x desired and xs. So this is how we can study the autopilot for the aircraft system, and the concept we have discussed in this course can be applied to any other dynamical system, because only the system will change, but the concept of designing control will be remain same. These are the basically introductory course, how we can come up with the basic controls for the different systems, of course, including the aircraft systems. And if you have any questions, you can reach me dkgiri, my email id at the rate of iitk.ac.in. I'll try my best to reach out with the solutions if you have any questions. Thank you very much and wish you all the best. And I hope you're gonna design your own autopilot for the systems for the aircraft or the UAV you are working on. Thank you very much.